Hi students, let's look at this question here, which is on sketching parametric curve and also to find the Cartesian equations given the parametric equation. So firstly, we were given x equals to 1 minus t, y equals to t 2t squared, where t is less than 1. Okay, so what we need to do is just bring out our calculator, right? Then go to mode and change this to parametric. Okay, the first thing is to change this to parametric. Then after which we're gonna go to y and just plot this in. This will be 1 minus t, and after which for y we have got 2t squared, right? 2t squared. Now the thing about parametric equation is that the calculator by default for the range of t, right? GC's default is I think it's 0 to 2 pi, I'm not mistaken, is t 0 to 2 pi or pi. Okay, so you could just see the window. You go to window settings, is 0 to 2 pi, and the maximum is 2 pi. So what we do is essentially what we need to change this to t less than 1. Okay, not 0 to 2 pi. So less than 1 would be t max would be 1. T minimum would be negative. Usually negative 10 would suffice, would be sufficient. So we just put negative 15 for negative infinity. So this is the graph that you're looking at. So you just sketch this graph. So change your window, go press window and change the t min and the max. That is the main thing about plotting parametric curve, because usually students forget about the range of t that needs to be keyed into calculator. So this is the shape here. If you're not very comfortable, like there are a lot of wasted underutilized space here, so you could just zoom box to the area where it's. So I'm just go over this side here, then press enter. Then I'm gonna go to this side, then I'll scroll it up, and I'm gonna press enter again, and that will be my graph here. So we could just press trace 0, and there will be this point here. Then I could just also place trace negative. Is it 1? Was it 1? 1, right? It's over here. So it's 102, and this is 10. So of course, some students will ask, how do I know which point will correspond to the parameter? Now, parametric equation just means that every point of the graph will have different parameter. All right. So you just imagine it's a housing address. So every point on the curve, you would have a parameter given to you. So what we could imagine is essentially if I put p into the parameter here, I could get different points here, right? So every p here, parameter here. So I'll trace it out, and because I want from positive 1 to negative infinity, so it's the graph that I'm looking over here. Okay, so what we need to do is understand that if you want to find if I want to find this intercept here, what I need to do is just find the parameter corresponding to that point. So for this case here, I have x equals to 1 minus t, and y equals to 2t squared. So I know that when x, okay, this is x0, x is 0, right? So the y-intercept here will be x is 0. So I'm going to find this is 0. X is 0, so I know that 1 minus t equals to 0, so t equals to 1. So when t equals to 1, y will be equals to 2, 1 square. Okay, so that's the reason why it's always good to just just key in calculator the maximum of the value t there. So if you look at this guy, you just press trace, you press 1, you usually will get the upper bound or the lower bound. You just intelligent, yeah, just give a guess. Okay, a guess. So that there will be that. Then this guy will be when y is 0. We know that t2 squared is equal to 0, so t equals 0. So x will just be 1. So this guy will just be 1, 0. In usually parametric equation, I will encourage students to just take a pencil, light pencil, to just label the housing address here. So we know, because for the subsequent part of the H2 math syllabus, we will have more what do you call it, complicated stuff that you need to deal with. So this is t equals to 1, then this is t equals to 0. Okay, the parameter corresponding to each of these points here. So this is how you draw this graph here. To change this to Cartesian form, what we need to do is to understand for Cartesian equation. I'm not going to find the domain of the Cartesian equation. I'm just going to find the Cartesian equation. So this case here, what we need to do is understand that Cartesian equation. So from parametric to Cartesian, the idea is to get rid of t, get rid of the parameter. Okay, so Cartesian form is usually just in terms of x and y. So this case here, we have x equals to 1 minus t, and after which y equals to 2t squared. So we need to find the Cartesian form here. So how we do it is that just make t the subject here. So t is equals to 1 minus x. So I'm just going to sub 1 into 2 because I want to get rid of the, what do you call it, the equation there. So, the t. So sub 1 into 2. Okay. Then I will get y is equals to 2 1 minus x squared. Okay. So this is the Cartesian equation that I'm looking at. So that's the Cartesian form. The Cartesian form is here. So of course the Cartesian form doesn't tell you the domain of the graph, but I'm just gonna find the Cartesian form here. Okay, so this is the first part. So let's look at the subsequent part B, which is an interesting one because it involves trigo and the domain is here. So let's just key in calculator. So here what I'm gonna do, I'm just gonna clear my x and y. Then after which just look at the sine t. Now this is important. What you need to understand is make sure your calculator is in radians. Whenever a trigo is involved, just check, make sure it's in radians, because I think sometimes if you don't change your, I strongly advise against changing GC into degrees, because a lot of times whenever you change your degrees, you forget to change back to radians, and then most of the questions will require you to use it in radians. Okay, 95% of the time. So use your Casio to store in I think the other scientific calculator, the non-GC one, you just keep it in degree is fine. For this, I would just strongly against you advise against changing this to degrees, because a lot of times students forget. So this is cosine t over 2. Key this into calculator. What we get. So the graph here that you look is, remember this is okay. So I'm going to zoom box because it seems like it's just there, that side there. Okay, this guy you're looking at. So I just scroll to this region here. Then after which we remember this 0 to 2 pi. We need negative pi over 2 to 0. So negative pi over 2 to max is 0. Okay, then you just graph it. This is the graph here. So I will really just trace 0 here. Then this will be, oh, this is 1.5. Then I'll trace pi over 2. I usually will just, okay, this is interesting, invalid, because this negative, oh sorry, negative pi over 2. So negative pi over 2. I just trace negative pi over 2. Okay. Key in, there will be 0, 0. So that's how I would sketch the graph. So just key in. So this is it. And then don't forget to just label. So we know that when I put the extreme point trace, I put 0. Because what I usually tell students is that you key into the 0 first. 0 is well, not inclusive of that point, is it? So 0 is 0.5. So when you sketch the point there, just make sure to put this as let me just erase this. T is 0 here, the parameter. Just put a faint, just point that point there. Okay, just that will be good. Done. So once this is done, put it in. Then this guy here will be my t equals to negative pi over 2. Just make it a habit. Okay, because subsequent part, we need to use the parameters. So once done, we need to change the Cartesian form. To find the Cartesian form, we need to get rid of theta. We need to get rid of parameter. So this case here, trigo is very common. So when we find trigo, we try and relate the two trigo ratio that you relating these two trigo ratio is important. So that we can get rid of it. So for sine and cosine, what you need to think of is just sine squared theta plus cosine squared theta is equals to 1. Okay, so this case here, what I'm going to do is actually just make x a subject. So I mean sine theta the subject. Sine theta is actually equals to x minus 1. Then cosine theta is given by 2y. So substitute this both into this equation with x minus 1 square. X minus 1 square plus 2y square equals 1. So this is an ellipse equation. So hence Cartesian equation will be x minus 1 square plus 4y square equals to 1. Okay, so that's how we do this question here for part B. You want to be more specific, we could just put actually x between 0 and 1 and 1, inclusive of 0, not inclusive of 1, and also y bigger than 0. Okay, so that's the important thing, but it's not part of the, I don't think part of the solution for this case. If you want to put it is x bigger than at least 1. Okay, at least 0 bigger than, yep. So let's look at C, tangent t and y sine t. So same thinking, calculator first. Here what we get is, just clear it, and remember to change the domain as well. So tangent t for x and sine t for y. So this is sine t. Then after which you have 0 to pi over 2. So just go zoom standard first. Just, oh wow, interesting. So zoom standard first, then this is 0 pi over 2. So we go to 0, then this we need to change it to pi over 2. Okay, key in, you get this graph here. Now this over here it may look like part of the graph, but it's not, because your calculator is not very good, especially in parametric form. They are not very good at interpreting the asymptotes. Okay, so this is actually part of the asymptote, but it's okay. We just zoom box to the region there first, then we'll see. So this is part of the asymptote. Don't worry about it. Later we'll discuss this. So let's just plot this in first. So how do we know that it's an asymptote? Partly is basically just experience. So you look at this t0. So what I'm going to do is just press trace 0. I know that it doesn't include this point here. Then if we trace pi over 2 would be 90 degrees. So you see this x is infinity, actually is y equals to 1. So there's something missing here. But what you need to understand is tangent 90 degrees. So tangent 90 degrees is undefined, is close to infinity. Okay, so you can't put 90 degrees there. It's actually a vertical asymptote. If you remember what you do in secondary school, the graph looks like that. This is x equals to pi over 2. All right, so we can't put 90 degrees into the equation here. So when this is 90, so when this is tangent 90 degrees, it will just be undefined. So you will get a graph something like that, where this is a vertical asymptote. You see that the graph here, if you key in, this is y equals to 1, right? So the horizontal asymptote is y equals to 1. Just put in there. Then you just put in the axis. Okay, so that's it. This is the graph that you get. Now once you get this graph here, I think oh, we're not inclusive of this point because it's non-inclusive. So usually I'll say is just label this as t equals to 0, not inclusive of 0. So there you go. This is 0, 0. Okay, then done. Now what we need to do is, how do we find the Cartesian form? So this case is x equals to tangent t, y equals to sine t. Okay, how do you relate both of them? Okay, so I think the main thing is to understand that tangent t and sine t, we could start off by relating them by using sine square t plus cosine square t. We know this is equals to 1. Then if you want tangent and sine, so just divide this by divide by cosine square t. That will give us tangent square t plus 1 is equals to secant square. Okay, great. So this is secant square. So this will not work. This will not work. So what should we do next? So the thing is, you want to get rid of a t. Okay, so you want to get rid of t. How would you do it? What I'll do is actually just change this sine t cosine square t is equals to x, right? Then from here, what I know is actually cosine square t. We know that cosine. Okay, so I can actually use this equation here. So this is x cosine t is equal to sine t. And this guy, this will just be y. This is y, right? Okay. So this case, I'm gonna get what I'm trying to get to is to make cosine find out what is cosine t, because now I have sine square t. I can utilize this once I'm able to express. So this is cosine square t Sine t is y over x. So this is 1 and 2. Sub 1 and 2 into 3. And 2 into 3. Okay? The whole idea is to get rid of the t. I don't care how I get it, but I'm just gonna this is sine, so it's y square plus y over x square equals to 1. So I think this is it. Y square plus y square over x square equals to 1. Okay, so there you go. Done. So I could also just put this out. I don't know whether I could, yeah. Oh, right. So make it nicer. It will be 1 plus 1 over x square equals 1 over y square. 1 over y square minus 1 over x square equals to 1. Okay. What we could do is just put as y bigger than, where y is between 0 and 1 and x is bigger than 0. Right. Yeah, seems like it. So there you go. So I have yeah, that's how you do part C. So I deduced the what do you call it, the domain here from the graph. That's all I did. Okay, so it's nothing like yeah, I just look from the graph, but I don't think you need this for the Cartesian equation. Okay, let's look at the last one, which is interesting one. Oh, this case here, if they don't write what is our t, we just assume that the t is for all real value. So for all real value, what we could do in our calculator, you just put negative 10 to 10, right? Or negative 15 to negative 10, negative 15 to 15 would suffice. This case here, go in there and just key in. So a key calculator, just make sure the window setting, I'm gonna just put negative 10 to 10, negative 10 to 10. From negative infinity to infinity. So just gonna graph it now. I'm gonna, okay, maybe I zoom standard first. Then window, negative 10 to 10. So graph it will be this shape here. Pretty cool. So this is the graph that I look at. Okay, so I think when as long as negative infinity to infinity is constant, what I'll do is I'll just trace. I put 0. I'll just put in the middle. Oh, I couldn't get t0 is 3, so we need to get this over here. 0 won't cut it. So when y is 0, we just try and find out what is when y is 0, what is the t value which corresponds to that. Okay, because if not, I couldn't get this value here. Okay, I'm just gonna do that. So I'm gonna do is I'm gonna just let y 0. I want to find out what is the parameter which correspond to this point. If not, I really couldn't. So when y is 0, just get the entire thing with 0. So 0 is equals to half e3t to e minus 3t. So this will be e3t. This is 0 minus 2. 1 over e3t equals to 0. Okay. Then this case here, what I'm going to do is e3t equals to 2. e3t. Then I'm going to cross multiply across. So this is e3t square equals to 2. This is interesting. So e3t, we could have e6t actually. So then 2. Okay. So then what we get is ln both sides, ln e6t, ln 2. Then I'm going to get 6t equals to ln 2. So t is equals to 1/6 of ln 2. So always check a calculator whether the value that you get makes sense. So this case here is ln trace. You put ln 2 over 6. Hopefully you get the answer there. There you go. So you get this weird number. Not really weird. I think this is seems very familiar. You could just key in, just put in the it looks like root 2, but we can key in the we just put in the x here. So put in the x. So x is equals to but e3t is equals to this e3t. Can just put it inside here. But e3t is equals to square root 2. Okay, we open up square root 2. So I could just sub square root 2 inside. Half root 2 plus 2, 1 over root 2. Rationalize the denominator, 1 over root 2. That will be root 2. Or is actually root 2. Okay, great. You can just slowly work it out. So this is root 2, 0. Okay, so this is root 2, 0. Then that's about it. I think then we could just indicate that this guy here is T ln 6 T ln 6 ln 2. Okay, that's it. That's about it. Then we need to find the Cartesian equation. I think the Cartesian equation not too bad. We just need to get rid of the T and so on, right? So D. This is also another what do you call it? Common question. How do we actually make the Cartesian equation? This is not too bad. What I'm going to do is I see that a lot of E3T here, so I just want to make E3T the subject. Okay, I don't really care. So from the first equation, I have 2x equals to E3T. I will cross multiply by 2. I'll get this guy here. So this 2y will be equals to E3T minus 2e minus 3t as well. So what I'm going to do is this is fairly okay, I think. So I get 1 plus 2. There will be 2x plus 2y equals to 2e3t. We add these both up, we just cancel out each other. So now what we get is x plus y is equals to e3t. Great job. Once we have this is the one which we are interested, because from here you can either choose y or x, it doesn't matter. So x is given by, we know x is given by half e3t plus 2 over e3t. Okay, they're going to do just sub this into 2, sub 1 into 2, and x equals to half x plus y, then plus 2 x plus y. Okay, I do not know what. Okay, we just 2x is equals to x plus y plus 2x plus y. Okay, we could leave it like that, or you see, is there another way to make it look nicer, or we can just leave it like that? Maybe just expand everything. 2x x plus y. Then we have x plus y square over here plus 2. 2x square plus 2xy. Oh, it looks nice now. 2xy plus y square plus 2. We could cancel this out. Cancel this out. What is left is actually x square minus y square equals to 2. Oh, we use hyperbola. So obviously we could you could leave it like that is fine. This guy here, just this case here, but oh no, you could just simplify it. But this case here, I'm gonna just put where x is bigger than 0. Okay, it's bigger than 0. Yeah, just that. But this is a Cartesian form. So that's how I do this question here proficiently. If you have any questions at all, please do let us know. I'll see you in the next question.